This is lesson 10.4, solving radical equations. Your objective is to solve equations containing radicals, also to identify extraneous solutions. Radical equation. An equation that has a variable and a radicand. Extraneous solution. A solution of an equation derived from an original equation that is not a solution of the original equation. You can solve some radical equations by squaring each side of the equation and testing the solution. Problem 1. Solving by isolating the radical. What is the solution of radical x plus 7 equals 16? First, we need to subtract 7 from both sides to get the radical by itself. Then we get radical x equals 9. We're going to square both sides, and that'll simplify to x equal to 81. Once you find your solution, always test to make sure that it works. So you're going to substitute that 81 back into the original equation, and the square root of 81 is 9. 9 plus 7 equals 16, and that works. Problem 2, using a radical equation. The time t in seconds it takes for a pendulum of a clock to complete a full swing is approximated by the equation t equals 2 times radical x over 3.3, where x is the length of the pendulum in feet. If the pendulum of a clock completes a full swing in 3 seconds, what is the length of the pendulum? Round to the nearest tenth of a foot. So first we can substitute 3 for t, since that's the time it takes to complete a full swing. And then we'll divide 2 on both sides. So we get 1.5 equals radical x over 3.3. Now we can square both sides of the equation, and we get 2.25 equals x over 3.3. To solve for x, we multiply each side by 3.3, and we get 7.425. So the pendulum is about 7.4 feet long. Problem 3, solving with radical expressions on both sides. Here we have radical of the quantity 5x minus 11 equals radical of the quantity x plus 5. We want to square both sides so that we can simplify that to 5x minus 11 equals x plus 5. Now we can subtract x from both sides and then add 11 to both sides. So we end up with 4x equals 16. Divide by 4 on both sides and we get x equals 4. Also, just to make sure that your solution works, you should always plug it back into the original equation. So 4 substituted for x, and we get 4 times 5 is 20, minus 11 is 9, so the square root of 9 is 3 on the left-hand side. And then we substitute x equals 4 for this one, and we get 4 plus 5 is 9, square root of 9 is 3, so we have 3 equals 3. That one works. Problem 4, identifying extraneous solutions. When you solve an equation by squaring each side, you create a new equation. The new equation may have solutions that do not satisfy the original equation. For example, here's our original equation, x equals 3. We can square both sides to get x squared equals 9. This is our new equation. Well, to solve for x, we would take the square root of x, and our solutions will be 3 and negative 3. However, in the example above, negative 3 does not satisfy the original equation. If we plug in negative 3 for x into the original equation, we get negative 3 equals 3, which is not true. This is called an extraneous solution. Always substitute each apparent solution into the original equation to check for extraneous solutions. What is the solution of n equals radical n plus 12? So first we need to square both sides. We get n squared equals n plus 12 when we simplify. Now we're going to subtract n plus 12 from both sides, and we get n squared minus n minus 12 equals 0. We can factor this quadratic equation and rewrite it as the quantity n minus 4 times the quantity n plus 3 equals 0. Using the zero product property, we're going to find the zeros. So we set n minus 4 equal to 0, or n plus 3 equals 0. We solve for n, and we get n equals 4, or n equals negative 3. Now we need to check that these solutions work. So we're going to plug in 4 into the original equation. Well, the square root of n plus 12, if we plug in 4, we get 4 plus 12 is 16. Square root of that is 4. N equals 4 on this side, that one works. If we do negative 3, we get negative 3 plus 12, which is 9. Square root of 9 is 3. However, n equals negative 3 on this side, so that one does not work. So the solution of the original equation is 4, and the value negative 3 is an extraneous solution. Problem 5. Identifying equations with no solutions. Sometimes you get only extraneous solutions after squaring each side of an equation. In that case, the original equation has no solution. Here we have radical 3y plus 8 equals 2. We're going to subtract 8 from both sides, and then we're going to square both sides of the equation. So we get 3y equals 36. We'll divide by 3 on both sides, we get y equals 12. Now we need to check. So we're going to substitute 12 back into the original equation. On the left-hand side, we have radical 3 times 12, which is radical 36, which equals 6, plus 8 is 14. However, that is not equal to 2. So, since this is not true, y equals 12 does not satisfy the original equation, and the apparent solution 12 is extraneous. Therefore, the original equation has no solution.